welcome back. So in the previous lecture, mostly we discussed about the drainage density, the importance of the bifurcation ratio, the shape of the basin, and the discharge. So basically the discharge we had a brief discussion in the beginning also, that discharge has been calculated and it depends on the basically the rainwater and the water availability and the cross sectional area. So that will give you the amount of discharge of the particular channel at particular point, and this discharge is important because this will tell you that whether the area will be affected during the flooding state or not, because the channel cross sectional area is extremely important. And one of the example which we discussed was of Kosi river from Bihar, and the reason of the migration or the frequent shifting of that river was because of the cross sectional area of the channel is very less, and that cross sectional area is been reduced during monsoon season, where the discharge is higher and more amount of sediment is been poured or deposited, eroded from Himalayas and deposited in the Indo-Gangetic plain. So channel cross sectional area reduces, and because of that the channels or the rivers are getting into frequent flooding states. So channel discharge is WdV, where W is the width, D is the depth, and V is the velocity of the water flowing through the channel, meter per second. Okay. So this is measured by gauging stations. Now, so if you have for example the cross sectional area, so for example the channel cross sectional area is 25 square meter, and you have the stream velocity is say around 5 meter per second, then with this what you can have is the discharge is 125 cubic meter per second. So if you reduce the cross sectional area of the channel because of the deposition or dumping of the bed load here, that will affect because the discharge, for example the rainfall in the region is constant, or you keep that parameter constant, the same rainfall, but and when you were having the cross sectional area was large, so easily that amount of water used to flow through the channel. But suppose this has been reduced and then your rainfall remains constant, so you have less area which is available to siphon out that amount of water through this channel, and what will happen is that it will spill over, result into the inundation or getting into the flooding state and inundating the nearby low lying areas. Now this problem is been experienced in most of the rivers, even the smaller channels or the smaller drainage basins close to the Himalayan front, because lot of erosion is taking place in Himalaya, and that is bringing a lot of sediment load. So many forest areas have been affected because of the silting of the channels. So the channels are filled with silt or finer deposits, so it doesn't have enough cross sectional area to carry the water or the discharge which is coming from the higher uplands or watershed area, which results into the flooding. So the flooding has destroyed a lot of flora and fauna, and they have affected, of course, the flora and affecting the animals also. So, this is the major concern in Uttar Pradesh and MP also, that this type of phenomena or the process is taking place, which needs an quick attention. Now, consequences of floods on floodplains. So, but again if we talk about the discharge and the time lag, then you will understand that if you alter one system, it is going to affect the another one. So, to some extent, the floods which we experience in the urban areas basically are man-made, and without having a proper understanding, because of encroaching the older parts of the channel and filling up the land and using it. So, you are and also by providing or by not providing the adequate drainage. So, this is, if you take the period of rain which is constant, for example, we take, so this is the time when the rainfall was experienced, and then this was the original stream flow, and then this pink one is comparatively the peaked one, and the discharge is also very high, whereas here the discharge is very low, and then time which has been taken to get into this point, that is the discharge, maximum discharge, was much higher, like the time was large or more, but here the discharge is more and the time taken is also very short. So, this is the stream flow after urbanization. So, what it explains is that before urbanization, this was the time lag of the channel to come into the flooding state, but after the urbanization, the time lag is very short, and also it has increased the discharge. So, that means to some extent what has been done was that you have occupied the area, you have allowed the water to flow as early as possible and with the more discharge, or resulting into the more discharge, and that is because the runoff has increased, the percolation is very less, and you have occupied or constructed more concrete jungles. So, this again is an important aspect, and we have to understand that because of a very trivial issues, we have entered into the lesser time lag because of urbanization. Now, example what we were talking about in a couple of slides about the landforms and the floodplains or the terraces. So, if you are moving on the higher ground or the older floodplains are this one here, but usually we love to get into the areas closer to the channel. So, what it shows here is that you have the valley and the natural channel and floodplain, what you see here. So, filled during construction. So, what usually we do is, in most of the cities, even in India, what you find is that the reclaimed areas. So, areas are been filled. So, that means the floodplains are been filled artificially, and that land or the area has been used for construction. So, this is the natural channel and the floodplain, adjacent floodplain. So, height of 25 years flood in unmodified channel. So, this is the, of course, the valley, the portion of the, so this is present of channel depth, but during the flooding state it will of course occupy the active floodplain, as I was showing in one of the satellite photo also. So, active floodplain should be avoided for residential areas or for industrial areas. So, height of 25 years flood in unmodified channel is marked here, this one. But of course, as we have, most of us have desire to stay in the floodplain areas because it is flat, more fertile, and then less work to be done for cleaning the region. Okay. So, it is artificially also filled for the construction of houses. So, building built in old 25 years floodplain, what has it has affected? It has affected that new height has been gained in 25 years and discharge. So, discharge is, so height is much higher as compared of the flood as compared to this one. So, this used to come up to here, but after filling for the construction and occupying the area, now this is the height of the flood. So, new height. So, this is what is happening in most of the urbanized centers, that because of occupying the floodplains, you have increased the height of the flood discharge. Flood hazard zones and management strategies, mainly that it says that flood hazard zone 1 active floodplains prohibits for business and residential complexes within flood maintain the area in natural state. Flood hazard zone 2, we have also seen the landforms, there is alluvial fans and plains with the channel depth less than 1 meter. So, again the density of the construction should be relatively low in such regions. Dry streams should be maintained in a natural state, or the density of the natural vegetation should be increased to facilitate superior water drainage and infiltration, because the vegetation will also help in infiltration. So, if the infiltration is higher and on the surface, then the runoff will be less, and that will result into the less discharge in the channels. So, construction of houses should be at higher levels. So, this is what we were talking about, the construction should be on higher terraces or the abandoned older floodplains. Then zone 3, these are basically the dissected uplands and the lowland slopes, drainage channels where both erosion and deposition processes are operative along the gradient of generally less than 5%, similar to the, so similar norms should be adopted as adopted for zone 2. So, roadways which traverse channels should be reinforced to withstand the erosion power of a channelized stream flow. So, mostly because you cannot avoid, some places you cannot avoid or realign your road construction, and you are probably crossing, suppose, a meandering river, then you will have to make sure that you make it like embankments, or maybe it should be the channel should be reinforced, so avoid the erosion and channelize the flow. Flood zone 4 are basically the areas of with steep gradients consisting of incised channel adjacent to the outcrop of mountain fronts characterized by relatively coarse bed load. So, these are the areas where mostly we were talking about the alluvial fan areas and all that. So, this again close to the front or piedmont areas or pediments. because these are the areas which will be adjacent to the mountain fronts, and those areas should be avoided for any construction. Now, restoration of the banks and the rocks, this is mainly most commonly seen in most of the areas. This is how you can do it. So, the erosional part, the outer part is the erosional parts. For example, if you take the cross section of channel cross section DD dash, then this is the deepest part and the outer part of the channel flow. This is the point bar here, and so most of the pool or the higher velocity will be seen on this side. And to stop the erosion, this is what has been seen, that it has been lined by rocks, rock fragments and the rock blocks, and finally what you see is a very beautiful outline of the channel here and restored channel. So, this is the restoration has been done, or reinforcement has been done, so that to stop the erosion and allow the water to flow through and through quickly. So, most of the cities, if you have, or if you are constructing a road across this, then this type of construction or the safety norms will help and stop the erosion. This is an example from US San Lorenzo River flood. This is before the city got affected in 1958 by floods, and this what you see, the photograph, is in 1967, after the flood control project was operated, and the channel was channelized, constructing the channel pathway. So, this helped in protecting the surrounding areas. So, this is very important. So, after construction of walls along the river bank, protected the flood waters to enter the adjacent areas. Now, this is the photograph from Tokyo. So, you can see that one of the channel of the major river is flowing across the Tokyo city. Tokyo is one of the best city in the world. So, you can see the residential areas are sitting very close by, but the channelized river has helped them not getting affected during the floods. Now, this is the condition of Ganga river near Kanpur in flooding state. So, mostly what is happening is that this is the high ground which you see the older floodplain, but the low lying area adjacent to that, most of the areas are been occupied, and like most of the years whenever the rivers are such rivers are in flooding state, we need to or there is a rescue of this people staying in the low lying areas, and most of the areas we need to evacuate. Then there is an example of the channelized flow which has been done in Gujarat. This is an example of Sabarmati river at Ahmedabad, where the whole area has been beautified and constructing the walls on either side, as I was showing from US, example from US, and this has helped for protecting the city which is developed on either bank of the Sabarmati river. So, this photograph is at the time of the construction, and this whole area has been used for recreation. They have parks, and then several like Chowpatty, what you see in Bombay. This has been used. So, this is after the construction. So, this whole area is what they call the river front, and it looks like this. So, this is the pathway which has been constructed for pedestrians, and then you climb up, you have the sandfill here. So, at least during during the flooding state, the water will not cross this wall. So, it helps in flood controls and siphon out the water as early as possible. So, some measures can also be taken, or the flood controls can be done by construction of smaller dams or the earthen dams or the barriers across the channel and stop the water in the region. Now, this is the breach of the earthen dam, which has been shown here, and this example, it shows that if you construct even the natural or artificial levees, because the breaching of or the breaking up of the levees can result into the flooding in adjacent state. So, this has been shown there. So, the edge of the river and then flooding landforms because of the breach of the levees. So, again there is an example which has been shown that before the channel was channelized by construction, how it looks like, and after that this is the same river San Lorenzo from US. So, I will stop here and we will continue in the next lecture with new topic on tectonic geomorphology. Thank you so much.